I'm making this little video to help you out with your fraction operations. Some of you have been struggling with how to add, subtract, multiply, or divide your fractions, and you know we're going to practice it every week. So hopefully you'll think to go back to check these different operations on this video when you need some help. Okay, so up first is adding and subtracting fractions. Now remember, when you're adding and subtracting, the first thing you need to do is get common denominators. Okay, so when we're looking at 2/3 plus 4x over 5, look at your denominators of 3 and 5. What kind of denominator can we turn them both into? Hopefully you can figure that out, that both of them need to become 15s. So I'm going to go ahead and set up my 15s. Okay, if I'm changing both of the original denominators, then the original numerators need to change also. So the 3, which is now turned into a 15, was multiplied by 5, which means I'm also going to multiply its numerator by 5. So 2 times 5 gives me a new numerator of 10. Okay, the 5 from my second fraction was multiplied by 3, so I'm going to multiply its numerator by 3. And 4x times 3 gives me 12x. Once we have common denominators, we're ready to go ahead and add across the top. So 10 plus 12x, those are not like terms, so I'm just going to leave it as 10 plus 12x. The denominator is 15. Those don't get added, it just stays the same. And that is the answer to my addition problem. Okay, subtraction isn't any different. We do need common denominators, so start off by finding what your common denominator is going to be. So with the 2 and the 7, it looks like I'm going to have a common denominator of 14. So I'll go ahead and set those up. Figure out what you've been multiplying by. So the 2 was multiplied by 7, which means I'm going to multiply the 3x by 7. So 3x times 7 gives me 21x. Okay. The 7 was multiplied by 2, so I'll do the 1 times 2 and get a 2. Again, it's time to subtract. Those are not like terms, so I can't actually subtract them. So I'll leave my answer as 21x minus 2 over 14. Okay, now for some multiplying. Now the good news is on multiplying is you don't have to worry about common denominators. All we're going to do is take each fraction and multiply straight across to get our result. So in the numerator I have 3x times 1, which just makes 3x. Denominator, 8 times 6 is 48. One thing you do need to do though is check to make sure that your fraction's reduced. The 3 and the 48, I'm pretty sure, can become a little smaller. And if you think about it, both of those numbers can be divided by 3. So we're going to go ahead and reduce our fraction by dividing by 3. Okay, 3x divided by 3 makes 1x, or just x, and 48 divided by 3 is 16. So that is the answer to my multiplication problem. You could actually have seen that earlier, that you're going to need to reduce, and you can reduce the first thing. Look at the 3 from the first fraction and the 6 from the second. Do you see how you can reduce those? If you had done that, reduce it just like a normal fraction, 3/6 reduces to 1/2, we now have a new multiplication problem. The 3 is turned into a 1, the 6 is turned into a 2, nothing else has changed. And now when I multiply straight across, I get right to x over 16. So you can either reduce first, kind of cross-cancel first, or you can reduce at the end. Doesn't matter which one. For the second problem, I've got a whole number times a fraction. Now when you are multiplying a whole number times a fraction, remember that a whole number, 5, is really just 5 over 1. So now I'm back to a fraction times a fraction. I don't see any cross-canceling to do. The 5 and the 3 won't cancel or reduce, and the 2 and the 1 won't. So I'm just going to go ahead and multiply straight across. 5 times 2x makes 10x. 1 times 3 makes 3. And I can't reduce that. I'm not going to go to a decimal. I'm not going to go to a mixed number. So that would be the answer for the multiplication problem. Okay, so our last fraction operation is division. Remember, we never actually divide fractions. Instead, we're going to multiply by the reciprocal of the second fraction. So when doing division, I'm going to keep the first fraction the same. It never changes. I'm going to change my division to a multiplication. And then the reciprocal means we're going to take that second fraction and flip it over. So instead of 1 over 2, I get 2 over 1. We know how to multiply. Just go straight across. So x times 2 makes 2x. 3 times 1 makes 3. And then again, make sure that you cannot reduce that fraction. 2/3 can't be reduced, so my answer is 2x over 3. Okay? It's the same thing when we're dividing, even if there's a whole number in front. I'm going to start out the problem by putting 8 over 1. So I see that it's just a fraction divided by a fraction. And then I'm going to keep the first fraction, change to multiply, and flip the second. So 3x over 4 turns into 4x over 3. And again, multiplying straight across, 8 times 4x makes 32x. 1 times 3 makes 3. I can't reduce the 32/3. I don't want to use a mixed number, and I definitely don't want to go to a decimal. So there's the quotient for my last problem.